Flipped classroom video for Maths A2 Unit 3, Inverse Trigonometric Differentiation. So we need to look at differentiating y equals sine to the minus 1 of x, so the inverse of sine x. We start by saying that if y is equal to sine to the minus 1 of x, then that tells us that x is equal to sine y by the nature of the inverse. And this allows us to differentiate. So dx by dy is equal to cos y. And remembering that via the chain rule we can say that dy by dx is equal to 1 over dx by dy. That means that in this case dy by dx is 1 over dx by dy, which is 1 over cos y. Also remembering that cos squared y plus sine squared y is equal to 1. And that means that cos y is plus or minus the square root of 1 minus sine squared y. Okay, and because sine of y is equal to x, we can rewrite that as plus or minus the square root of 1 minus x squared. So that gives us dy by dx is plus or minus 1 over the square root of 1 minus x squared. Now, it's not satisfactory to leave that uncertain, so we need to think about this plus or minus business, and the best way of doing that is to have a look at the curve itself. So, if we have a look at the sine to the minus 1 curve, remembering that it's only defined between minus 1 and 1, and that the range has to be between minus pi by 2 and plus pi by 2, to make it a one-to-one function. So we're restricting sine x in a sense when we create sine to the minus 1x, and we have to have it one-to-one for an inverse. Now if we look at that curve, we can see that the gradient of that curve is very definitely positive all the way along. So we can conclude, because dy by dx is greater than 0 or positive, then dy by dx is equal to 1 over the square root of 1 minus x squared. Okay, now we need to do a similar job with y equals cos to the minus 1 of x. So we start with y is cos to the minus 1x. We use the fact that it's an inverse function to say x equals cos y. Dx by dy is therefore minus sine y. Dy by dx, using 1 over dx by dy, is minus 1 over sine y, and then we can use our cos squared plus sine squared is 1 to end up with sine y is equal to plus minus root 1 minus x squared, as we did before, which gives us that dy by dx is minus or plus. And the reason for that inversion of that sign is that we had a minus 1 over sine y. So when you combine a minus with a plus or minus, it becomes a minus or plus. So that's minus or plus 1 over root 1 minus x squared. And again, we need to have a look at the graph. So this time, with the cos to the minus 1x curve, we can see that it has a negative gradient all the way along. So that tells us that dy by dx is less than 0. And that tells us we need to take the negative square root. So we have dy by dx is minus 1 over the square root of 1 minus x squared. And that is a sort of reason, if you like, for writing minus plus on the left at the bottom of the left-hand column. We should write minus plus because that's what's actually happened mathematically. We had minus times plus or minus, which gives us minus or plus. But it also can remind us that for the cos to the minus 1x differentiation, we do end up with the negative, just because the minus being on top in the minus plus symbol gives us a little clue if we're struggling to remember the graph or just to remember it generally. Okay, so we now need to have a look at tan to the minus 1 of x. So, same job, y is tan to the minus 1x, therefore x is tan y. dx by dy in this case is sec squared y, and so dy by dx is 1 over sec squared y. Now this time we're going to use an allied or connected equality which comes from sine squared plus cos squared equals to 1, and that gives us tan squared y plus 1 is equal to sec squared y. Therefore sec squared y is 1 plus x squared, because x is equal to tan of y, and that means we can conclude that dy by dx is 1 over 1 plus x squared. And we don't have a problem with plus or minus here, and if we look at the graph we can see that it is positive all the way along, and we can also see that as x gets very large the tangent is gradually tending towards 0, which is what happens to the function 1 over 1 plus x squared when x gets large, and similarly when x is getting negatively large the gradient is tending towards 1. We can see that on the graph, as does the value of 1 over 1 plus x squared when x gets negatively large.